So this is paper 2 of your autumn mock. Obviously this is a calculator. Let's see how we get on. So, question 1. What have we got? The highest common factor of 90 and 126. Now I would do highest common factor by doing factor trees to identify the prime factors. So just keep going down your factor tree until you get to your prime numbers. So it's 3, 3, 2 and 5. Do the same with 126, so 63, 2, and then I would have 7 and 9, and 3 and 3, and then your highest common factors, or highest common factor comes by multiplying the common ones together. So I've got 2 in both, I've got 3 in both, and actually another 3 in both. So highest common factor is actually 18. Right, simplify. 2a cubed times a to the 4, so that's 2a to the 7. Now some division, so just take it a step at a time. 12 and 3, which gives you 4. X to the power of 5 divided by x squared. You take away the power, so that's x cubed, and y. 4x cubed y. Okay, number 3. Joe went on a holiday to Spain. Okay, he spent £320 on flights. He stayed for 3 weeks, €560 each week, and he hired a car for 15 days. Exchange rate was £1 to €1.12. Work out the total cost in pounds. Okay, so what I would do, I would convert everything into pounds to start with. So 560 divided by 1.12, which gives me £500. I'll do exactly the same with the car hire. And once I've got it all in pounds, it's then just a hopefully fairly straightforward calculation to work out what, so obviously using your calculator, that's handy, 18. Right, so we've got these flights plus 3 lots of 500 plus 15 lots of 18. Tap that all into your calculator, gives us 2090. If there had been more than 1.12 euros to a pound, how would this affect your answer? So if this exchange rate was different, he would have actually had to, because we'd be dividing by a bigger number, he would have spent less. Cheaper holiday, could have gone for longer. Okay, question 3, done. Number 4. Translate shape P by a vector of 5 minus 4. Well, the top number tells you how far across positive, so we're going right. 1, 2, 3, 4, 5. Minus 4, so it's going down. 1, 2, 3, 4. So that's one corner. The shape doesn't change. So basically your new shape ends up there. Okay, so that's a translation by 5 minus 4. Describe fully the single transformation that maps A onto B. Okay, well, it's not a translation. It's not an enlargement. It is going to be, it's either a rotation. No, it would be the other way around if it was rotation. So it's reflection, and it's got to be a reflection in the diagonal line. That diagonal line is y equals minus x. Better actually put that it's a reflection as well. Pretty sure the mark scheme would have given you a mark for reflection and a mark for actually getting the line. Right. What have we got now? Frequency polygon. We've got 90 sticks. We've got the length, the frequency. Jenny drew the frequency polygon below from the information on the table. Frequency polygon is not correct. Well, you've got to plot these points in the middle. So it should be 4, 12. Yep, this all looks promising. 16 to 24, so that's 20. 24 to 32, so it should be at 20. Right, okay, so the last point hasn't been plotted in the middle. So last point not in middle of the group. And they shouldn't be enclosed. It shouldn't be closed off. Well, it's always very tempting because it's a frequency polygon. You think it needs to look like a polygon. You don't need that line there. No, I can't spell enclosed. Right on, enclosed. There we go. Okay, so the two things. Last point is wrong. Shouldn't be enclosed. Right, question 6. Rectangle has length 8 centimeters and area of 20. The length of the rectangle is increased by 2. The area of the rectangle is increased by 4. The width of the rectangle decreases by less than 5%. Is number correct? Well, we've got a rectangle. Let's actually draw some diagrams. So it is 28. Well, 8 times 2.5 is 20. And then the new rectangle is 24 by 10 to 2.4. The width of the rectangle decreases by less than 5%. Okay, well let's work out 5% of 2.5. 2.5 times 0.05. For some reason I haven't done this. 2.5 times 0.05, which gives you 0.125. So Noah is correct. It's reduced by 0.1, which is less than 0.125. Okay. Number 7. So we've got A, B, which is 2 to 3, and then we've got B to C, which is 5 to 6. We need to show that A to C is 5 to 9. Now, so we can actually put them all in one ratio, we need these two numbers to be the same. So if we times these by 5, we've got 10 to 15. So I've times by 5. And I times these by 3, I have 15 to 18. So now our ratio can be written as 10 to 15 to 18, which is basically A, B, C. If we take out A and C, we've got 10 to 18, so it is half them both, 5 to 9. So divide by 2. And then we got 5 to 9, which is what we wanted. Right, question 8. ABC are points on a circle with diameter AB. ABC is a right angled triangle. Circle theorem, we know that. Calculate the area of the circle. Well, so the area is pi r squared. So we do need to work out what AB is, because that's going to be our diameter. So we've got square roots, a bit of Pythagoras, which gives us 6.824. I'm going to carry my answer when I work out the area. So the area is basically going to be pi times that divided by 2 squared. Just using the answer from a previous calculation, which gives me 36.6, making sure I'm working to the 3 significant figures. So always be careful with your rounding. Number 9. This graph can be used to convert between kilos and pounds. Pounds, kilos. Work out the gradient of the straight line. Right, okay, so gradient, change in the vertical divided by change in horizontal. So I'm going to pick a point. I'm actually going to pick that point there, which I think is 18. So that's 18 by 40. So it is 18 divided by 40, which is 0.45. Now, if your numbers are slightly different, they do give a margin in the mark scheme. So it doesn't. I think it said between 0.4 and 0.5. Okay. What does the gradient of this line represent? Well, each time you go up one, so it's the conversion, it's how many kilos per pound. Yeah, so every time there's one more pound, you get a 0.45 of a kilo, which sounds about right. Right, number 10. Cumulative frequency. So they've actually given us a table there. We've got 80 students, so when we get to the bottom it needs to add up to 80. So the cumulative frequency is basically a running total. So 4 add 16 is 20, 20 add 30, and just add them up, so that's 68, and that is 80. Good, so they actually match up with what we need. On the grid opposite, draw a cumulative frequency graph of from your table. Now this would be obviously a lot easier for you to do. We always plot at the end of the group, so 25 was 4, well that's 10, so each little square is 2. So then I've got 30, oh that's handy, 30 and 20, 35, 50, 40 is 68, that's going to be one little square down, and 80. And then we can do it from 0, 20. Nice smooth curve, and it is meant to be a curve, not dot to dot. Okay, use your graph to find an estimate of the median. Well, the median is going to be at 40, so if I go across there, go down to there, now each one, because it goes from 30 to 35, each one is 2, so that is 33. And again, it gives you a little bit of a margin there. Now, use your graph to find an estimate for the probability that this student, don't forget it's probability, took longer than 38 minutes to complete his test. Well, 38 minutes is going to be up there, so about there, which gives us 60, 62, 63, maybe 64. Let's go for 63. So that is 17, because you want the ones above that. So 63 up to 80. So 17 over 80. And again, they give you a little bit of a range there. But don't forget the probability. All right. Lisa bought a house. The value of the house increased by 1.5% each year for 2 years. At the end of the 2 years, the value of the house was that much. Okay, work out the value of the house when Lisa bought it. Well, this is a compound interest, so we don't know what the original is, but we do know we increase by 1.5%. So find your multiplier, 1.015, 2 years. So we need to square it, and that is going to equal the value in the question. So now, a bit of rearranging, it's multiplied, so we have to do divide. Luckily, we can use our calculators. Let's just divide by 1.015 squared, which gives us 120,000, which is kind of a sensible figure. Okay, so I'm on to a bit of algebra now. Expand and simplify. Right, well I'm going to expand the first two brackets to start with. So I've got x squared, basically x times x. I've then got 5x and a 3x, so a plus 2x, and then a minus 15. I'm now going to do a table, because I've got to multiply everything by x plus 4. So times these, hang on, that should be a squared there. So I've got x cubed plus 2x squared minus 15x times through by 4. Being really careful with your multiplication signs, making sure you get all that right. So we've got 1x cubed, we've got 6x squared, we've got minus 7x and minus 60. Okay, make sure that's clear. Expanding our brackets, 3 marks. Right. Oh, a lot of graphs. Question 13, 9 graphs. Write down the letter of the graph that could have the equation y equals cosine x. Well, cosine x is a curve and it goes through 0, 1. So actually, it's that one. That's the sine curve. That's the cosine curve. Right. Write down a letter of the graph that could have the equation right. So 4 over x squared. Now, 4 over x squared is one of these graphs that's in 2 bits because x cannot be 0. So it doesn't cross the x-axis. So it could be potentially that one, potentially that one, potentially that one, potentially that one. Now, it's also always going to be positive because if we put our values of x in, we're squaring them. So actually, that's got negative values, so it can't be that one, as does that one. So actually, it's this one, because it doesn't cross here, and all the values of y are positive, which they always will be, because you're squaring it. So that's D. Right, write down the letter of the graph that y squared equals 4x. Right, I'm going to rearrange that. Y equals the square root of 4x. Okay, I'm just rearranging that, the square root of 4x. Let's have a little think about the values we're likely to get. If we've got x, can't be negative, can't have negative values, so actually it is either going to be this one or this one. Let's have a think. What happens when x is 0? It can actually be... It's not shifted along because 4 times 0 is 0. Square root of 0 is 0. So there you go. It's actually A. Okay, just by sort of working through it, realising the values you could have and you may not have. Okay, and you've obviously got 2 values that are identical, 1 plus, 1 negative, because you've got this plus and minus when you square root. Okay, number 14. Diagram shows an isosceles triangle ABC. AB and AC are equal. Right, okay. M is a midpoint. N is a midpoint. Prove that MBC is congruent to triangle NCB. Okay. So let's have a little think. We know MC is equal to NB. These bits, because they are half the sides of an isosceles triangle. CB is a common side. So we've got 2 sides, and actually these angles are the same as well, aren't they? So MCB is equal to NBC because of isosceles triangle again. Therefore congruent, but we must state the rule of what we're using to prove they're congruent, which is side, angle, side. Side, angle, side, and exactly the same on the other one. Okay, and they do like to see that actually written down. Right, number 15. G is a function such that gx is x cubed plus 3 find G. Right, so we've got G minus 3, which is basically going to be minus 27 plus 1, which is minus 26. Quite a few of you wrote minus 28 there. Next bit, we need the inverse. So actually, put it equal to y. Do your rearranging. And therefore, your inverse, remember to substitute your x back in. It's the cube root of x minus 1. Okay, we've just done that, so hopefully we've got those. Now, we're walking to school. Walks to school, so we've got walks to school, doesn't walk to school. If she walks to school, the probability she will be late is 0.3. If she does not walk to school, the probability she will be late is 0.5. Work out an estimate for the number of days that Sarah will be late on the next 20 school days. So let's have a look. We've got walk, not walk, which is just going to be 0.8. 0.2, but then if she walks, she's late, not late, so 0.3, 0.7, and these are slightly different. Late, not late, so that's 0.05, and that must be 0.95. Work out the number of days that will be late on the next 20. So we want late, so we need this one. Multiply along the branch, so that's walk and late. This one is not walk and late, which is 0.01, which gives us, when we add them together, quite handy, 25%. 25% of 20 is 5. So she's going to be late for the next, for 5 days out of those 40. Okay, right. Here are two right-angled triangles. Jolly good. The lengths of the sides are in centimetres. We're given that. Find the size of angle C. So we can use this, I think, to work out the value of x. Because we know tan C. Tan C is basically 2 over 3x, opposite over hypotenuse. We know cosine D is 3 over 4x. Some algebraic fractions, look at that. Right, so let's add them together, but we've got to make them common denominator. So that's 8 over 12x plus 9 over 12x, which is 1.5. So that gives us 17. 12 is 18x, so x is 17 over 18. But don't stop there, because we're not just working out x, we need to work out the size of angle C. So we need to do tan inverse 2. Yep, sorry, 2, and I'll put this in brackets, I'm just thinking where we're going with this. And then we need 3 times 17 over 18, which actually you can do all on your calculator, which gives you an angle of 35 degrees. It says to the nearest degree, so 35 is fine. So we worked out the value of x and then substituted it basically back into here to get our angle of C. Right, so what have we got next? Number 18. First 5 terms of a quadratic sequence. The nth term of the sequence can be written in the form of a n squared plus bn, where a and b are integers. Work out the value of a and the value of b. Okay, so let's look sequences. Best thing to do is always look at the difference. So let's start with our first difference. So that's 7, 13, 19 and 25. Okay, so they're not the same, but we wouldn't expect it on a quadratic. So let's look at the second difference, which is 6. As soon as you know the second difference is 6, you know that A is 3. Remember, always half the second difference. So let's work out 3n squared, which is basically our squared numbers times by 3. So 1 squared is 1 times by 3 is 3. 4, which gives us 12. And then we've got 3 squared is 9, 27. I'm going to do one more. 16 is 48. So that's 3n squared. But our sequence is 1, 8, 21, 40. So we need to take away 2, take away 4, basically the difference here, because we're here and we want to get here. This is our sequence. Probably not set this out very well. Minus 6. Right, that's the first time. So actually, these are our terms doubled. So that's our first term doubled. That's our second term doubled. So actually, our sequence, see below, is going to be 3n squared minus 2n, because each time we're taking away 2 lots of the position. So it's minus 2. Okay, sorry, I haven't said that out very well there, but it is 3n squared minus 2n. Right, number 19. T is equal to m divided by f. Right, straight away I'm thinking it's a bounds question. We've got 3 significant figures, 1 decimal place. By considering bounds, work out the value of t to a suitable degree of accuracy. Okay, so basically we want to work out the upper bound, the lower bound, and see how it pans out. So for m, we've got 120.5 as the upper and 119.5 as the lower. Going to do exactly the same with f. Really clear so everyone can see it. 25.65, 25.55. Now, upper value of t is where you need to think, because you want the biggest number you can do divided by the smallest value of f. Tap that into your calculator, you get 4, and I'm going to write them all out and I'll show you how we're going to arrive at our answer in a minute. So that's the upper. Do exactly the same with the lower, except now I want the smallest possible number on the top divided by the biggest possible number on the bottom, which gives us 4.6588. Now, suitable degree of accuracy. These both round to 4.7. So actually, the suitable degree of accuracy to your answer is 4.7. Because basically, your answer is anywhere between those two values, so it's always going to be on 4.7. Right, what have we got here? So it's that sector of a circle with centre O. We know this angle is 50. We know that's 12. Work out the area of the shaded segment of the circle. Right, well, we need to work out this distance here. So I'm going to make a right angle triangle, and I can, because these are both radii, make that a right angle triangle, make that 6. So basically we've got sine of 25 degrees is equal to opposite over hypotenuse. So OC is 6 divided by sine of 25, which is 14.197. Now I've got that, hopefully we can actually work some stuff out. So if we work out the sector area first, which is basically the area of a circle times by the angle we're interested in. So it's 50 over 360. 50 is the angle, times by pi, times by the radius squared, which gives us 87.94747 actually. Okay, so that's the sector area. So now if we work out the area of the triangle, and then we just take the area of the triangle away from the area of the sector. So I'm going to do half AB sine C. So I've got half times, right, that's actually the same on both, so 14,197 squared, so I'm going to times it by itself, times by sine of 50. Tap that into my calculator, I get 77.19997, and then basically I just want the distance and the difference between them. So shaded area, that, take away that, 10.7, and because I'm going to 3 significant figures, fairly easy to follow. I've got sector area, area of triangle, shaded area. Probably could write to find OC there, just so everyone can see what the steps I've worked through. But you really need to work on making sure your method is clear. Right, question 21. I think this is the penultimate one. Maybe. Not quite. Right, so we've got 2 points. Diagram shows a sketch of a graph with equation y equals AB. I think that says minus x to the power of minus x. Okay, so this point here is 0, 6. And this point here is 3 and 0.75. We need to work out the value of A and the value of B. Right, well, if we substitute this value in, we know that, so we're going to work with 0, 0, 6. We've got 6 for the y is equal to A, B to the power of 0. Well, B to the power of 0 is 1. So actually, A is 6. So we've got one point already. Now, we can do exactly the same again with these values here. So now we're using 3 and 0.75. So we've got sorry about that, 3 and 0.75. So let's stick those values in. We've got 0.75 is equal to A, which we know is 6, B to the power of minus 3. So 0.75 we can divide by 6, which gives us 1 over 8 is equal to B to the minus 3. Well, B to the power of minus 3 is the same as 1 over. So I've got 1 over 8 is equal to 1 over B cubed. Well, B cubed is equal to 8. So actually 2 to the power of 3 is 8. So B is indeed 2. Right, on to the next question, which I think this is the penultimate question. What have we got? 3 similar solids. So we've got A, B and C. We've got surface area 24 and 54. The height of B and the height of C are 3 to 7. Okay, 3 to 7. The volume of A is 72. So let's actually label this area volume 72. Okay, and this is scale factor. Okay, let's see what we can do with this then. We don't even know what we're doing. C is made of wood with a density of 0.14 grams per centimetre cubed. Well, we're in centimetres anyway. Work out the mass of C. Well, density is equal to mass over volume. So we know density, so we've basically got 0.14 is equal to M over, we need the volume of C. Okay, so we actually need the volume of C. So let's work back. What have we got? So 3 to 54, but that's so. Because this is area, I'm going to see how many 9s go into 54, which is 6, and then it's been halved to 3. So if I therefore work out, this is the area factor, so I've basically gone from, I've done 3 squared, which is 9, then I did 54 divided by 9, which gave me 6. So now I'm going to do 24 divided by 6, which is 4. Square root 4 is 2. Right, okay, so now I've got the scale factors 2 to 3 to 7. To get the volume, I need to cube 8. So if I look at A, I've done 2 cubed, and I've ended up at 72. So 8, so that actually is 9. Okay, so now what I need to do is I need to do 7, so for volume for C is basically going to be 7 cubed times by 9, so it's in the same ratio. Yeah, and I've used the volume factor, which is basically 3087. So to get my mass, I'm going to do 0.14 is equal to mass over 3087. So mass is those two multiplied together, which is 432.18. Okay, so it's all to do with these scale factors. Keeping these are for lengths, so then you've got to square them, which gives you 4 and 9, but these need to be kept in the same ratio, so that's times by 6, that's times by 6. Likewise, this one then is cubed, so 8 has to be times by 9 to get 72, so 7 cubed has to be times by 9 to get that volume. Okay, sorry I didn't start off very well there, but hopefully that clarifies it. And then the last question, we've got to solve a quadratic. So is it a quadratic? No, it's not. It's we've got inequality. So we've got difference of two squares. So let's rewrite it like that. Okay, and now we can solve it. So we can add 4 to each part. Okay, this is working out nicely. We've got an x squared in the middle, so we need to square root them. So we get 3, 4, but we also mustn't forget when we square root it, we get negatives as well. So we need x to be bigger than -4, but less than -3. So that actually is your solution set. Okay, so x is between 3 and 4, or between -4 and 3. Okay, so there we go. That's the paper 2 done.